4 involves absolute value equations. We're going to talk about them in equations and in inequality. We haven't talked about this since back in 2.1, but if you remember, absolute value means actually, in simplest forms, the amount of jumps or spaces you would move from 0 to that value. You can't jump negatively, so even if you were going to -8 and you start at 0, you would make 8 jumps. So absolute value tells you jumps that are positive of that value. So let's go ahead and put it in action with some equations. First we're going to do equations. Equations means there's an equal sign there. So if I was going to solve the equation x minus 2 equals 5. Okay, the part that is going to be different with the absolute value is we are going to actually use the phrase inside the absolute value symbol, x minus 2, and we're going to say that could either equal a positive value or it could equal the negative value. X minus 2 is going to equal a -5, or could equal a -5. Because the absolute value makes a negative positive and leaves a positive as positive. Now that I have the two different possible solutions, it's just a simple equation to solve again. So get my like terms together, adding 2 to both sides leaves me with x could be equal to 7, or solving over here, same thing to both sides, getting like terms together, balanced equation, and this time x is going to equal -5 combined with a positive 2 would give me -3. Okay, so my solution then would be that x could be equal to -7, or it could be equal to -3. I could check that very quickly by putting those in to see if that is true. 7 minus 2 is 5, so the absolute value of it is also still 5, so this is a true statement. Let's put this one in. -3 combined with a -2, and our absolute value. Is that equal to, whoops, sorry, go back up to the original statement, 5. So -3 minus 2, or add a -2, equals -5. It's in the absolute value sign. Is the absolute value of -5 5? Yes, it is. So both of those are true statements. We have checked our solution. We're going to do the same thing on this one. However, we have a more complex equation here because we have part of the equation, the phrase, in absolute value, and then we also have an extra constant term. So my first step on solving this is going to get it to be a simple equation like the one in example 1. So I am going to get rid of my extra term here first, extra constant term, using balanced equation. And then I end up with just the phrase 2x minus 7 that was in the absolute value symbol. And on the other side of the equal sign, I would get 9. Now I'm going to follow the same process I followed on the example right before this. I'm going to take my phrase. I'm going to put it as a phrase. You could even put it in parentheses if you'd like instead. That phrase is either equal to 9 or 2, whoopsie, let's try that again, 2x minus 7, that phrase, it's going to be in the absolute value, could also be equal to -9, because inside the absolute value it could be equal to -9, and the absolute value would then change it to a positive 9, like our original simple equation right here. So Solving the same way we have been. Balanced equation, adding 7 to both sides gives me 2x equals 16 as a possible solution. Solving for a single variable, divide both sides by 2. You're going to get x could equal 8. Same thing over here. Let's get our like terms together. Get rid of our constant term from that phrase. This time we have 2x, looks like a smiling equation here, equals, combining a negative 9 and a positive 7, I end up with a negative 2. Divide both sides by 2. And my other possible solution would be x equals a negative 1. Negative 2 divided by negative 2 divided by 2 would be a negative 1. Let's go back to our original. Now you could go back to the simplified one, or perhaps you want to go all the way back to the original one just to be safe. So let's see if we can do that. Let's do 2 times 8, 16, minus 7. 16 minus 7 is 9. Absolute value doesn't change that. It's still 9. Is 9 minus 5 equal to 4? Yes. Let's use our other one now. X minus 1, or x equals negative 1. 2 times a negative 1 would be negative 2. Combined with the negative 7 gives me negative 9 inside the absolute value symbol. The absolute value symbol then changes my negative 9 into a positive 9 minus 5 equals 4. So both of those equations or both of those solutions will work for that. I'm going to go ahead and pause a minute. Of 6.4 will now deal with the absolute value when it's with inequalities. This one is a little bit different, so you'll have to kind of follow along to really understand what's going on with this concept. But straight from the book on page 354, you will see an investigating absolute value inequalities, where they're telling you to do the guess and check and revise to find the values of x that could satisfy that inequality. Now, this is kind of like our Santa Claus moment, so I'm going to go ahead and do just a couple of these from the book. I don't want to make it more complicated than it needs to be, so we will then move on and do a couple like you will be doing in your assignments. So, if I say the absolute value of x needs to be less than 2, all right, that would mean that x, that absolute value, that x, as we were doing on the equalities, x would either be have to be less than, and it can't be equal to 2, or it could also be to the negative 2, because if I put inside absolute value would then change it to a regular 2. So I could put that my x needs to be less than my positive 2, but it would also need to be greater than a negative 2. Again, the same thing we did with the equalities. We changed this value here to a positive or a negative. Now, if we do that same thing for number 2, let's do that same thing again for number 2. Now, this is a little nicer because there is an equal sign. That might make it a little bit easier for you to understand. I'm going to do the x plus 2, that phrase, same as I did with the equalities, needs to be greater than or equal to 1. But my other one would be that my x plus 2, and instead of being able to just say negative 1, as I did when they were an equality, I have to go back to my rule about changing things to negatives in inequalities. When I change by multiplying or dividing, which is what I'm doing here, I'm multiplying this answer by a negative 1, I need to reverse my sign. So again, I'm going to just go ahead and solve and I would have that x needs to be greater or equal to a negative 1. And then in this one here, I can say that x is less than or equal to a negative 3. Now, Miss Hurley gave me a little trick on this that I will explain to you when we're on the screens with just one at a time. Let's go ahead and do this one then. X minus 3 is my phrase. I'm going to just do the equality part of it. So it's going to be less than or equal to, and I can just say 2. But then to change it to a negative 2, like I was doing in the equality equations that just had a equal sign, this time I need to reverse my sign because I'm multiplying my answer by a negative 1, giving me a negative 2. Sorry, I'm almost running out of room there. So if I do this one, oh my goodness, let's redo that. Sorry. If I add 3 to both sides, balanced equation rules still apply here. I would go ahead and on this one, I would get x needs to be less than or equal to 5. On this one here, where I multiplied, so I reversed my sign, I apologize for the writing. This one would be that x is greater than or equal to 1. Now this particular one here, and I will explain the little trick in just a minute, I could write this as just one sentence or expression because I could say that x is less than or equal to 5, but I could also put my other equation here, and 1 was less than or equal to x, so x is greater than or equal to 1. So I could combine those. This is an and statement, cheated there a little, and this is an or statement. I will explain how that works out and how you can tell that before you even go to solve on the next screen.